Oh yeah, oh yeah.
NASA's Parker Solar Probe is a mission to explore the sun.
Sun?
How can it do that? Why won't the spacecraft melt? Excellent question.
Excellent question.
You
Why
can't
won't
face
the
off with
spacecraft melt? It won't melt because it wouldn't have reached. It wouldn't have reached where they've said it's reached. Imposible, amigo. Esto no pasa. Ni aquí, ni en ningún lado. What we are looking at here, I just can't get over the second. They want to do a leap second, a leap year second, a leap second. I need to focus just on this for now. My mission here today is to put things into perspective, right? I know for a fact that most of you don't know how to put these things into perspective, and I know because of the things that you're saying, right? I can just tell. I know what you don't know, I know what you do know, I know what you think you know, but mostly I know what you don't know. And it's so much, right? It is so much. I'm not being arrogant, it's just, please listen, right? 4 things. The sun's diameter, 1. The Earth's diameter, the moon's diameter, and the distance between the sun and Earth. Those are the main things. We then got the distance between the moon and Earth, but that's like a minor thing, right? The big ones, the 4 big ones, sun, Earth, moon, and the distance. Last week I did a 13.9 diameter sun example, remember? And it works out with a 13.9 centimeter diameter sun. The 150 million kilometers comes down to 15 meters, right? So today, what I have done, that 1,390,000, I've doubled it. All we really care about is these numbers here at the beginning. Times 2 is 278. 139 times 2 is 278. Alexa, what's 139 multiplied by 2?
139 times 2 is 278.
Thanks, Alexa. Do that lately. Right. We have got 200 or 27.8 centimeters. It does not matter how big you do your sun, right? The easiest way to get the distance from the sun to planet Earth is by this measurement here, its diameter. You don't need numbers. You could just draw it freehand. And then you get its diameter from one side to the other, and you need 108. And you just keep walking until you get to 108 sun diameters. How do we know this? Because the distance, 150 million, divided by the diameter of the sun, gives us 107.9. We call it 108. There are 108 sun diameters in between the sun and Earth. Simple. You do it that big, then you need 108 of those between the sun and Earth. You do it that big, you need 108 of these. And it tells you exactly where planet Earth is. And then you've got to get Earth to scale, right? So this week, I've doubled it. From 1.39 to 2.78, or 278 from 139. 108 suns, diameters, multiplied by 27.8 is 30. It's 30.02. It's exactly what it needs to be, because when we did the 1.39, it was 15 meters. We only got halfway down the yard, remember? So today, we're going to go the extra mile, or the extra 15 meters. When you're putting stuff like this into perspective, proportion to scale, the bigger you can do it, the better it is, because you can see there's more detail. If I only did the solar system between here and here, the Earth, you're not going to see it. right? And the sun's only going to be like this. It's just the bigger it is, the better, the more detail you see. Now we have got all the way down to the cone. You'll see it in a minute. So at 27.8 centimeters, if I draw that sun diameter this size, I need 108 suns to find out where Earth is, and that 108 times 27.8 is 30 meters. Earth, I do the same. What we do to one, we do to the other. 12,742 times 2 is 25,584. But everything is getting divided by, it was 100 million. So now it would be 50 million, I do believe, right? That's why we're getting these numbers. Alexa, what is 1,390,000 divided by 50 million?
1,390,000 divided by 50 million is 0.0278.
See how that works? 0.022, whatever it was, 0.00278. It's this that's important, right? We know that it doesn't matter how big the sun we draw, all we need to do to get an accurate sense of where Earth is to that scale is by getting 108 of those sun diameters. This big, this big, this big. No ruler needed, right? Just 108 of that size. Earth, 12,742 times 2 is 25,584. We divide that by 50 million, because this is now at a 50 million to 1 scale, we get 2.5 millimeters. So planet Earth has a diameter of 2.5. So there should be 109, I think it is, diameters. Boom, 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 boom. Alexa, what's 2.5 multiplied by 109?
2.5 times 109 is 272.5.
270 is good enough. We're always rounding up and down, right? So bang, it locks in, it ties in. The moon, 3,476 kilometers times 2, we've got to do the same to everything, 6,952. But divided by the 50 million is going to be 0.69. Very good number. When we did the 15 meters, God, my mouth is dry. When we did the 15 meter with a 13.9 diameter sun, it was 0.34. Remember, it was 1/3 of a millimeter. We've doubled it. Now it's roughly 2/3 of a millimeter, right? And we've got the distance, which is 30 meters. We've got everything we need, right? We've got 30 meters. We've got a 2.5 millimeter Earth. We've got a 0.69 of a millimeter moon. The distance between the Earth and the moon. The average distance between Earth and the moon is 384,000 kilometers. If we divide that distance by the diameter of Earth, the same as we do dividing the diameter of the sun into the distance, we get 30. So we know there are 30 planet Earths in between Earth and the moon. Always. So it doesn't matter what size you do your Earth. If you draw your Earth first, all you need to do is go 1, 2, 3, 4, 5, 30. That's another thing. When they draw Earth and the moon, you never get that impression. It never gives that impression, does it? The moon is 30 Earth diameters away from us. 30. They always make it look like 3, 4, it's just around the corner. It's not. All right? This is by not knowing that and not using it to put things into perspective, you can easily lose track of reality. you can easily start thinking that all of this is really easy. It isn't. All right? So have we got everything we need? We have, and the sun is still there. We've got a diameter of 27.8 centimeters. That's going to give us 30 meters distance, right, between the sun and Earth. We've got a 12,742 kilometers multiplied by 2 is 25,584. Divided by 50 million, because it's 50 million to 1 what we're talking this scale, we get 2.5 millimeters. That's the diameter of Earth. The moon, 0.69. There are 30 Earths in between the moon and Earth. 30 times 2.5 is 7.5 centimeters. So our scale today is going to be showing, oh, please don't tell me I've forgotten my ruler somewhere. I think I took it inside. Right, that's really, hang on, I'll be right back. I wanted that ruler because it's got the measurements on it, and I did little drawings. I wouldn't have left it down by the. Maybe I did. Let's gamble. Right, I'm not going to take a walk. I'm hoping that it's down there. I don't know how much battery we've got. We're really living on the edge here. And we're going to go down. Honey, I shrunk the solar system. This is all about the NASA Parker Solar Probe, right? And the claims that are being made. If you don't put things into like perspective, proportion, then you're not going to know what's what. That is going to be our sun. It's that size, 27.8 centimeters. Let's go. I'm hoping the ruler was down there. So I was taking measurements to make sure that we could see the sun and the Earth and Moon at the same time. There it is. Ah, cool. Could not really be anywhere else. This is 30 meters. This cone, right? Now, on here, what we have is, there's Earth, 2.5 millimeters, that's its diameter, see? So you've got the millimeters above it. If anything, it's a little bit too big, but not by a lot, right? So this is to scale. When you look at that moon, that sun, well, you can't really, yeah. See it? Right? As far away as it is, that's the scale. Now I'm trying to zoom back out, right, so that we can see this, and this is what I wanted to see. Keeps coming in and out of focus. That is Earth, 2.5 millimeters. And over here is the moon at 0.69, 2/3 of a millimeter. And the distance in between them 30 planet Earths, right? So all we need to know is that to the left there, 2.5 mil is Earth, and to the right, that's the moon, and that is the correct scale. So I'm going to leave that there, right? Now, what we have is a solar probe, is leaving the planet that has a diameter of 2.5 millimeters. That's not going to be much of a solar probe, is it? It's going to be tiny. Now, this is what I mean by putting things into perspective. Shining lasers and all sorts onto that foil to try and get a sun. And then it occurred to me, now, you will not get a better indication of things to scale at 50 million to 1 than this right here. Right? Right, that's already coming down a bit. That sun. Drops. Right, let's not waste any time here. We've got that to scale, right? It's only the sun you're looking at there, so when that drops down, it is going to drop down a little bit because that's just the way it goes. Right? Now, this is what you'd see. This is what we see from planet Earth. Let's go. Right? 2018 it is. That 2.5 millimeter dot on that piece of paper, which is Earth to scale, right here, launches a probe. Now, understanding that planet Earth is 2.5 millimeters, you have to appreciate how tiny the solar probe would be, and it's coming this way. Not 10 million kilometers, not 20, not 30, not 40 or 50 of the 150 million kilometers, or 60, 70, 80, 90 or 100 million. No. It's come to within 140 million kilometers of Earth. It arrived. It's been this close to that sun. Remember, everything is to scale. So, the heat that we feel 150 million kilometers away, and this tiny, tiny, tiny probe that wouldn't even be a gnat's whisker diameter wise, has been travelling for what, 6 years, and it's already orbited the sun 3 times. The closest to date is 10.4 million kilometers from the sun, and it's going to get to within 6.2 next year. It's going to come within 4 point something million miles of the sun. That's 6.2 million kilometers. Now, can anybody see a problem with this scenario? How big is the solar probe? On one of those videos, they showed the solar probe caught up in a coronal mass ejection, and it was filming it. So it was facing the sun, right? And the sun just spat. And all of this. Alexa, how fast are the solar winds that come off of the sun?
According to an Alexa Answers contributor, 448,000 miles per hour.
Alexa, how fast are the solar winds that radiate from the sun?
From uchicago.edu. The solar wind is a flow of particles that comes off the sun at about 1 million miles per hour and travels throughout the entire solar system.
Now we have a probe, cheeky looking probe, heat shield at the front, so that's the heat shield, right? And it's this distance, right, to scale. If we look at the overall picture, that I don't even know why I need to go on about this. If you can't see what I'm trying to say by now, if you're going to keep this denial thing going on, oh, you don't know what you're talking about there. Listen, seriously, I do know what I'm talking about. It's got the white plate with the carbon and 97% air, right? And it was at this distance, orbiting the sun, speed it's doing, and as the sun launched the solar flare, you saw in the video, solar winds were going like this, right? And it was filming out the side. Possible? Of course it's not possible. Diameter of 1,390,000 kilometers. And the probe is about 7 or 8 sun diameters away from that. Do you have any idea what that would look like? And it's filming a coronal mass ejection. This water cord with the radiator, hand in oven hot, hand out not, and it's filming a coronal mass ejection that in all likelihood, if it was headed towards Earth, would knock satellites dead, and some of them out of the sky, but not the Parker probe. This is where we part ways, isn't it? It's where we part company, right? You've listened up until now, and then we get to that bit where, really? There is no way that a water-cooled solar probe has been travelling for 6 years, right, has gotten to within 10.4 million kilometres of the sun. That's its closest so far. So maybe the one before that was, I don't know, 20 million and then 30 million. But this thing, it's weird because these plates, right, they say the plates protect it from the heat. It is, it's the oven. It's the oven syndrome. Hand in oven, oven hot, hand not. Oven hot, hand not. Sun, all of it's everywhere, isn't it? When you're close to it, you can feel it here, can't we? Sometimes, right? And let's say planet Earth is over here somewhere. The Parker probe, to scale, is here, even closer, right? How? How would it be this close and film out that side all these photons going crazy? Look at the NASA Parker probe, it's in the sun, it's in the coronal mass ejection, people. Ingenuity, you've been beat. It's impossible, it's a joke. It's a joke, right? This is for a dumbed down audience. This is something that people who have been blasted with absurdities all of their life, but they just don't know what's real and what isn't. I guarantee you, this did not happen. They need to explain how it happened. They need a lot of explaining to do. So much. Every single mission. Everything's starting with Roma and the telescope. That's where we'd start. So, okay, so Roma is the cornerstone, the pinnacle, whatever it is, of the research of the speed of light. But he was using a telescope. How do you explain that then, Mr. Scientist? And what would they say? Well, there is no well, right? There is no, well, he was using a telescope. Even if there were a light delay, he would have not picked it up with a telescope. So everything that they have ever said about Roma is wrong, right? Everything is connected. So what's the next one? Was it Wheatstone or Bradley, James Bradley, who came? I don't know. We know Galileo had nothing to do with it because he wouldn't have been thick enough to ask two of his assistants to go and stand on opposite hillsides with a lantern in their hands and say to them, right, go, I'm going to time it with no stopwatch. It's the insults to people's intelligence that just keep coming, and everybody's missing them, right? So much of this stuff, it's just so stupid, right? But as long as people believe it, you believe the NASA solar probe. Oh, there's more to come this week. But if you can believe something so tiny to travel that distance and get to 10.4 million kilometers of the sun from the 150 that it was at and survive, then you are Gonski. Because this is an absurdity. Hasta la vista, baby. Hasta la vista, baby. I love this tune, though. It's my birthday. I had a tequila shot. Woo!
NASA's Parker Solar Probe is a mission
Yes,
to explore the
the
sun.
sun.
How can it do that?
How can it do
Why
that?
won't the spacecraft melt?
I don't know. Why? You tell me.